to bring some issues that are already there in your layer 2 networks but you may not be aware of. So the primary focus of this session is to give you that eye-opener that these problems exist and some of you may not know about it and there is something you can do about it. Okay? So the session is not primarily about how to configure Cisco devices or per se, but primarily the issues that are lying in the layer 2 networks. Okay? So here's the agenda that we're going to talk about, and as you can see, main meat of the session is about the different type of layer 2 attacks that exist in the layer 2 network. So we are briefly going to talk about the layer 2 landscape, what it looks like. Then I'm going to focus on 6 different types of attacks in layer 2: VLAN hopping attacks, MAC attacks, DHCP attacks, ARP spoofing, and there are some general spanning tree type of attacks. Okay? So the format of this session is that I'm going to talk about each individual attack. For example, DHCP attack. I'm going to give you a background of how DHCP works and how an intruder can abuse some of the underlying issues within the DHCP protocol. Okay? So as one disclaimer before we continue, that this session is assuming that all these attacks are possible if you are in a layer 2 switched Ethernet environment. Okay? If you are not using a switched Ethernet environment, some of these attacks may not be possible, or on the opposite, it could be easily possible if you're, for example, using a hub. But I doubt anyone is using hub in these days. Most of the people are using switched network, Ethernet network. Most of the testings that I'm going to show you in terms of configuration and in terms of the outputs have been captured from Cisco Ethernet switches, but that does not mean that you are not able to solve these problems on non-Cisco devices. Obviously, there is always solutions on other boxes as well. Say again? The slides will be published online. I think they're going to do it as I speak or once I finish. Yeah, but I was told that they're going to publish it soon, today, sometime today. Again, as I told you earlier, that this is not a comprehensive talk about how to configure Cisco switches. The topic is not about how to configure Cisco devices. It's about what different type of attacks exist in a layer 2 network, and obviously how to solve them if you're using a Cisco switch or a non-Cisco switch. Okay? Another disclaimer is this: most of these attacks are about the IPv4 networks. Some of these attacks may not be possible in the new IPv6 networks. Okay, so there are 2 different protocols, 2 different generations. These attacks are mainly about the IPv4 network. So, first of all, a little background about OSI model. Okay, so this is all where it began. Where is our root cause? What is the real issue about the layer 2 networks? So first of all, why worry about layer 2 security? We always say, look, I have a great secure network from a layer 3 perspective. I'm using VPN, I'm using encryption, I'm using cryptography, I'm using all sorts of different firewalls and intrusion protection. So why worry about layer 2? You know, who cares? But the problem is that there is an underlying issue in the OSI model. When OSI was developed originally, many, many years ago, they didn't think about so many security vulnerabilities and issues. And OSI model was designed very independent to each other. So for example, if you are working on a layer 3, it doesn't care what happened on layer 1 or layer 2 or layer 4 or layer 5. Each layer is independent to each other. Okay? All it cares about the corresponding opposite side of the layer that it is communicating to. So for example, this is the source and this is the destination. So if you are working on a transport layer, all it cares about transport layer on the other side. It doesn't worry about the data link or the network or the session on this side. Okay? So what is the problem? The problem is if one layer is compromised, for example, in this case, our session is about layer 2. So if layer 2 is compromised, all the above layer are compromised, irregardless of your firewalls, irregardless of your VPNs, irregardless of your cryptography, whatever you're using. Okay? So it all begins at layer 2. Okay? So when it comes to networking, layer 2 can be your weakest link. And most people don't pay attention to their layer 2 security. They always worry about layer 3 security and above. Okay? So one of the things that we often use in layer 2 is VLANs. Okay, everyone aware what VLANs are, right? So generally speaking, when you ask the network operations or the security operations, whose responsibility is to secure layer 2 network? If you ask the security guys, they have no clue. They'll say, what? Layer 2? I don't care about that. I manage the firewalls. I manage the layer 3. If you ask the network operation guys, they say, well, security is not my concern. You go to SecOps. So they bounce you around. Nobody wants to take ownership or responsibility to protect your layer 2. Okay? So this is a fine line that you have to draw, that whose responsibility within your organization is to protect the layer 2 network. Is it the network team or is it the security team? Okay? Just some statistics, and mainly I'll show you the numbers here. That from a survey that was done by FBI and a number of other organizations, more than 50% of the people think that they are attacked by the external network. They think that the internal network is very like, you know, an angel or some most protected segment in the organization. They don't realize that more than 50% of the attacks originate from the internal. They don't realize that. And I'm telling you, I have seen many customers, many organizations that they are wide open internally and they try to protect the external from coming in. But they don't realize that their own internal network is so wide open that somebody can abuse it so easily. And most importantly, they are being abused or they are being, sorry to say, screwed up, but they don't even realize that that's happening. Okay, and I'll show you a few examples during the attacks. It happened, I'll just tell you one story. I was in a bank, in an organization, and they asked me to do some design clinic for them. So I went there, I just plugged in my laptop in one of the ports, and I was live. I virtually took down their entire network, and they didn't even know about it. And then I went to their CIO and said, look, do you know you can't do this, you can't do that, like in your network? And he said, oh yeah, maybe it's something, some routing issue, some network issue, something. He is not even aware how easy it is for someone to take down a network within a few seconds if I am within the organization. So without much delay, let's go to the meat of this presentation, which is to talk about the different types of attacks. So as I told you earlier, that the format of this session is I'm going to talk about each individual attack. I'll give you a little bit of background, what VLAN is, then discuss what are the countermeasures and what you can do to resolve the problems within the VLAN attacks. So first of all, a little background about VLANs and trunking. So here is a basic network, like 2 switches, different desktops, and you have multiple VLANs across your organization. So in this case, you have VLAN 10 on this switch, VLAN 20, another device on VLAN 20, or another device on VLAN 10, a typical network that you see in your day-to-day routine. And this link between the 2 switches is called a trunk. And what is a trunk? Basically, a trunk is a device that connects 2 network segments into one, and a trunk is a link that can see all VLANs. Okay? The important point that I would like to make is a trunk can see all VLANs, all traffic. There is no restriction unless you have explicitly restricted the trunk to be able to see only a specific traffic. But in generally, trunk can see all traffic. So if there are 5 VLANs, trunk can see all 5 VLANs. Okay? There are different protocols that a trunk is using. .1Q and ISL and all that. So I'm sure you're aware of that. Another little piece of info, DTP, Dynamic Trunk Protocol. DTP is used to negotiate trunking. Remember this slide that I showed you? So how does this trunk establish? How do you make it work? So there is a protocol called DTP, Dynamic Trunk Protocol, which is used to establish this trunk between two switches. Okay? Now, and there are two protocols, as I told you, .1Q and ISL. DTP is also used between an IP phone and a switch. Okay? So DTP is not only used between two switches, but it can also be used between a phone, because phone is acting like a switch. This is the important part here, that there are different states of DTP in a switch. There is a state called auto, on, off, desirable, or non-negotiate. And you can look it up when you go back and do some little more research, what are the differences between these states. But theoretically, from a Cisco switch perspective, most of today's iOS switches are on desirable, if I believe. So if you power up a brand new switch, two switches, and you hook them up back to back, they will be auto desirable. So that means they can negotiate a trunk without you doing anything. And what I'm saying is, if you take a laptop, plug it into the switch, and if the laptop or if the computer is also capable of running DTP, it can negotiate a trunk by default without you doing anything. So that's not good, right? Because and we'll see how that's not good. So here is how the problem starts. So let's say this smart guy here, an intruder, wants to abuse this functionality of your switch, the DTP functionality. So what he does, he also talks the same protocol that your switch talks. So for example, if your switch is using .1Q, he also enables .1Q on his link. And what happens? He is able to negotiate a trunk with your switch by default without you doing anything. So all he's doing is playing over here. And once he is successfully able to negotiate the trunk, that means that he is able to see all the traffic, not only the VLAN that he is supposed to be in, but all the other VLANs that he is not in. So in this case, originally he was in VLAN 20, but now after the trunk has been negotiated, he is able to see VLAN 10 and VLAN 20, and for all the other VLANs which are on your switch. So that's not good, okay? So how do you solve that? We'll come to that part later, but this is the big issue. And trust me, this is on every switch in your organization, on every single port on this switch. If you have 10 switches and you have 24 ports, 240 ports are wide open to your intruder to just plug in and negotiate trunking. Okay, so you have to do something about that. Another problem that can be abused with this phenomena is an attack which is called VLAN hopping attack. What happens is that you, as an intruder, what the intruder does is sends double tagged frame to the switch. So he sends two tags, two encapsulations of .1Q. You see here 1 and 2. Because we all know that the switch only strips off the first tag. It doesn't care how many tags are attached to the packet. So the switch, when the packet arrives, when the frame arrives, it strips off the first .1Q and says, yeah, I don't know which port does it belong to, so I'll send that frame to the trunk. And when the frame goes to the trunk, this switch also strips off the second frame, and the frame was supposed to go to some victim or some guy which he was originally trying to attack. Mind you, this attack is one unidirectional only. It is not two directional that he is trying to connect and get the packets back. It's unidirectional. So this is called double tagging, double encapsulation VLAN attack. Okay, it's very, very easy to do. There is no science behind this. I mean, it's so easy to launch this type of attack. By the way, most of these attacks that I'm going to talk about, this does not require any special hacking skills. Anyone can do it. So it's another eye-opener that don't think that a smart hacker can do all this stuff, and any layman can do it. So what can we do to protect against these type of issues? So here is a list of summary of things that you can do to protect against this basic VLAN hopping and double tag type of attacks. First of all, in your switched environment, always use a dedicated VLAN ID for all the trunk ports. If we go back to our slides, if you look at this issue that we said that, okay, this can negotiate a trunk, make a note of this, requires a trunking configuration of native VLAN to be VLAN 1. So if your switch is in native VLAN 1, and if this guy is also in native VLAN 1, and by default, all switch ports are native in VLAN 1, then only this is going to be possible, okay? So the best practice to protect this type of attack is always use a non-VLAN 1, like for example VLAN 5 or VLAN 50 or VLAN 100. Create a VLAN which you explicitly use for trunk ports and not the access ports where your servers and your desktops are connected. Don't use that VLAN for anything else. Create a new VLAN and use it for trunk ports. Yes.
That would be the dedicated or untagged VLAN for the trunk?
Yes. You can tag it also. See here we are saying also that use all tag mode for native VLAN on trunks. But the point is use a dedicated VLAN, which is not used for other access ports.
And no user traffic.
No user traffic. Exactly. Another thing is disable all unused ports and put them in an unused VLANs. What does this mean? So for example, if you have a switch, 24 ports, 10 ports are being used, 14 ports are blank, are idle. So what you do, proactively put all those ports in a dummy VLAN. Let's say VLAN 100, which is not being routed anywhere. It's a kind of a null placeholder VLAN for all the unused ports. Why? Because if you don't do that, and if you keep the default port configuration that is desirable, it can negotiate anything, or it can be in any VLAN or whatever. So by default, purposefully make all those unused ports access ports and put them in some dummy VLAN. Make up a VLAN which is not routable in your network. Yeah, because, for example, the trunk configuration, if it is negotiating in a desirable mode, it can negotiate a trunk, right? So we are not only protecting against double tagging, but we are also protecting against the basic VLAN hopping attack. Okay? So as a point, the summary of this slide is be paranoid. Do not use VLAN 1 for anything. If I do, there is a command on the switch called show VLAN. If I do show VLAN, it shows all the ports associated to different VLAN. When I am auditing your network, I'm monitoring your network, and I do show VLAN, I should see no ports in VLAN 1. So when you go back to your organization, do show VLAN, and if there are multiple ports, unused ports in VLAN 1, you are in a problem. Okay? Disable auto trunking on all user-facing ports. User-facing as in the ports that are supposed to connect desktop computers, servers, or laptops, or whatever. So any port that you know is not designated for trunk, is designated for a user, you must disable DTP, the dynamic trunk protocol, on that port. And how do you do that? There is a command on the switch port mode access. So you are saying to the switch that this will never be a trunk port. This will always be an access port, switch port mode access. Okay? Explicitly configure trunking on infrastructure ports. So in this diagram, if you know that there are two switches connected back to back on, usually it's port 24 or port 48, the last port, whichever port it is, you know explicitly which ports are connecting your switch back to back. So explicitly configure them trunking. Don't keep them in desirable, auto, or all those different types. Hard code them. Switch port mode trunk, switch port native VLAN, blah, blah, blah. Okay? So let me repeat your question. The question is, Cisco recommends auto or desirable on both sides. Don't keep auto and on, or auto and desirable, so two mismatch on either side. So again, the answer to your question is, I'm not talking about Cisco recommendations. I'm not going to go in Cisco syntaxes. All I'm saying is, if it is a trunk port, hard code it, make it trunk. If it's not a trunk port and it's a user port, disable trunking altogether. Don't leave it negotiable, don't leave it auto, don't leave it on, just turn it off. And how do you turn it off? By making it an access port, by the command called switch port mode access, full stop. Once you do switch port mode access, no matter how many times you plug in, and it will not negotiate trunking, DTP. No .1Q, no ISL, it will not negotiate anything because you hard coded it. Make sense? Use all tag mode, as I was saying. You can also use tag mode, use PC, voice, VLAN access, blah, 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 all I've covered that. So, that was the basic VLAN issues. There were two types of VLAN attacks that we talked about, the basic VLAN hopping and the double tagging. And we discussed some of the best practices and recommendations that you can do to avoid those two types of attacks. Okay?
Does your recommendation solve the double tagging?
Yes. Double tagging will be solved by this stuff. Disabling, no, double tagging will be mainly because of the VLAN 1. So you put them in a dedicated VLAN and it will not work because your user that is on the other side, the hacker, doesn't know which VLAN your native VLAN is. He will be in VLAN 1 native, right? Or something dummy native VLAN. Okay? Any other questions? No? Okay, so now let's talk about MAC attacks. So again, a little bit of introduction of MAC addresses, and then we'll talk about what issues are. Okay? So what is a MAC address? MAC address is a 48-bit hexadecimal number that creates a unique address of your layer 2 address of your Ethernet device. Okay? The 48-bit is split in two halves, each 24/24, and the first 24 bits is designated for the manufacturer code, which is assigned by the IEEE. So for example, in Cisco, all Cisco devices their MAC addresses will start with this. The other 24 bits are specific unique interface addresses. So for example, if you have your laptop, your PC, or your server, each Ethernet device has a unique MAC address which is assigned by the manufacturer. So if you buy a Cisco product or a non-Cisco product, they have their own way to assign the unique MAC address. And when you put all FFF, that's supposed to be broadcast, meaning to everyone on the network. Okay? So it's a basic introduction of what the MAC address is. What is a CAM table? CAM stands for Content Addressable Memory. CAM table is a repository, a database on the switch which holds all the MAC addresses which are connected on your switch. Okay? So if you have a switch which has 24 ports and there are multiple PCs, servers, desktops connected to it, it holds the Ethernet MAC address of each individual device into its database. And that database is called the CAM table, Content Addressable Memory. So one important thing to understand about this attacks is all CAM tables have a fixed size. So all switches, when you buy a switch, whichever switch, whether a Cisco switch or a non-Cisco switch, remember that the CAM table has a fixed memory size. And that is where our issue lies in this attack, what the attacker does. Okay, so I'll show you about that in a minute. So let's review what happens in a normal switch environment. Let's say there is a switch, 3 ports, there is 3 computers, each have a unique MAC address. So there is a MAC address A, MAC address B, and MAC address C. And this table here shows the CAM table. So all the database of the MAC addresses on your network. So as you can see, the current table shows that MAC address A is hooked up, connected on port number 1. MAC address C is connected on port number 3. Okay? But the switch doesn't know where MAC B is. Okay? Now remember, when you power up a switch first time, brand new or first time, or even if you power cycle the switch, what will be in the MAC table, in the CAM table? Can anyone tell me? 0, nothing. MAC address CAM table is blank, is 0 first time. It learns, it It builds the database as and when the hosts communicate with each other. So for example, MAC address A sends a packet, maybe an R packet, asking for where is Mr. B. So B is unknown to the switch, right? It checks in the CAM table, it says, B, I don't know where B lives. Does it live on port 1, port 2, or port 3? It doesn't know. So what does the switch do in that case when he doesn't know where B lives? It forwards the frame, which we call broadcasting. It forwards the frame to all the ports on the switch, all the ports. If you have 100 ports, it will forward it to all 100 ports on the switch. Yes, except the one it came in of. Okay? So what it will do, as you can see in the diagram, it forwards it to all the ports in this scenario. Okay? Now, whoever is B will reply. Obviously, this guy, when you send it to C, he won't reply because he's not MAC address B. Only this guy will reply. So when this guy will reply saying, yeah, I am B, here I am. So what does the switch do? The switch learns where is B. B is living on port number 2, and he populates the CAM table. Right? He will populate the CAM table. Now I know where B is living on port number 2. So this is called the learning process, the MAC address learning process. And that's how the CAM table gets built over the time, throughout the time frame. Okay? So that's the basic behavior of how the CAM tables are built. So now what happens the next time? The next time A wants to send anything to B, what does the switch do? The switch looks up the CAM table. It knows B is living on port 2. It sends it to B. So this guy never sees the traffic which was sent to B. And that's how the switch should work, right? If A wants to send anything to B, switch should send it explicitly to the port where B is living. It should not send it to port 3 where B is not living, right? That's the basic behavior. So now what happens? How can we abuse this basic architecture of how the switching works? There is an attack called CAM table overflow. And remember, I told you that each switch has a fixed size of CAM table. So it can hold maybe 10,000 MAC addresses or 5,000 MAC addresses or whatever. So the idea of this attack is to flood the CAM table with bogus MAC addresses and fill it up. Okay? And there are many, many different tools available. There is a very common tool called MacOff, which can do easily. There is another called Yersinia, which is also another monkey attack tool. And basic idea is to overflow the CAM table. And I'll show you in a figure how that can be done. So let's say this is the CAM table from our previous slide. We have a completely fully populated CAM table. Okay? In this scenario, assume that my CAM table has a size of 3. Okay? So my CAM table can only hold 3 MAC addresses. So what does this guy try to do here? See, he's trying to say, I am MAC address Y. He's spoofing MAC address. He's sending you bogus MAC address. So whenever he sends Y, what does the switch do? He says, oh, Y is living on port number 3. Okay, I'll update my CAM table. Then again he says another, I am MAC address Z on port number 3. The switch says, oh, there is Z also living on port number 3, and so on. So this guy keeps on sending bogus MAC addresses until your switch CAM table is fully populated with all bogus MAC addresses, all pointing to the same port. So why is he trying to do that? What's the objective? Can anyone guess? Exactly. So what happens the next time A wants to send, coming back to our original issue, when A wants to send any traffic to B, what is the principal architecture of switching? When the packet comes in, switch says, okay, you want to go to B, let me check my CAM table where Mr. B is living, and B is he can't find B in the CAM table. So what does the switch do? It floods the packet to all the 100 ports, right? And that way this guy is able to see the traffic to B, which he was not supposed to see in the first place. So by launching a simple CAM table overflow, which takes less than 5 to 10 milliseconds, trust me, and he can see all the traffic that he's not supposed to see. So such a simple attack that person can launch. Here is just a Mac-off tool output. You just run from a Linux box. You can dump all the 100,000 bogus MAC addresses in 1 second. So what happens when a CAM table is full? The switch will turn into a hub. Basically now your switch is kaput, all the CAM table is filled, and it will start broadcasting, flooding into each and every port. It becomes like a hub, and the intruder sees packets that it's not supposed to see. Okay? So remember I told you, I was emphasizing that whenever you buy a switch, the CAM table size is full. So you have to also check what's the CAM table size, right? Because some switches have really small CAM table size. So how can you protect this type of attacks? There is a simple solution which is called the port security. And every switch, most of the switch, whether you use Cisco switch or a non-Cisco switch, this feature is very common, easily configurable, very easy to configure. It's called port security. And basically what it does, you can limit the number of MAC addresses on a specific port. So in that case, port number 3 was trying to flood the MAC addresses, right? We can say on port number 3 only limit 2 MAC addresses or 3 MAC addresses. So it cannot send more than 2 MAC addresses or more than 3 MAC addresses. If it does, what will the switch do? It shuts down, it cuts it off. It says there is something wrong. I'm seeing multiple bogus MAC addresses and it's not supposed to be like this. Okay? So in this case, see, for example, this guy was sending hundreds of MAC addresses by applying the port security feature and locking it down to only 1 MAC address. So when the first MAC address comes, fine, the switch will accept it. When the second MAC address comes, it will lock down the port. It will say, sorry, no more. Okay? So port security limits MAC flooding attack and locks down the port. There are various actions that you can configure. You can say shut down the port, or you can say restrict the port, or you can do different type of actions on the when it detects that there are multiple MACs. Any questions here?
Other than shutting it down, can you just say only accept the first 2 or just throw away? I'm thinking of a situation where you might have a port where multiple people are going to plug their laptop or something like that.
Okay, very good question. What the question is, just to repeat, that how do you tell the switch to be dynamic, that accept 2 MAC addresses, but don't lock down those 2 MAC addresses. I mean, it can be anything. Today, I'm connecting to a laptop, and maybe your laptop is connecting, maybe somebody else is connecting. So you want to tell the switch that I want 2 MAC addresses, but they should be dynamic. Is that what your question is? Yes. You can achieve that, and actually that was on my next slide. I'm just flipping and I'll come back. In the past, in this functionality, in this feature, in the past, you would have to type in only the MAC address you are going to allow in that port, as you said. But today, the feature has enhanced, and you can configure dynamic MAC addresses. So you can tell the switch, I'm not going to hard-code MAC address 1234, because today 1234 is connected, but maybe tomorrow 345 can connect, right? So you are telling the switch that learn dynamically. Whatever is connected, as long as it's 1 MAC address, I'm accepting it. You disconnect that PC, you put another PC, 1 MAC address, it will accept it. Okay? So yes, you can do that. And you can lock down to any number of ports, 2, 3, 4, whatever. Now, in addition to your question, there is another situation where you have an IP phone. And when you have an IP phone, obviously your user, if most of you have used IP phone, you would see there is a connection at the back of your IP phone for data. So your IP phone is connected to the switch, and your laptop or your PC is connected to the IP phone. So essentially, remember last time I told you that the phone is working like a switch. It negotiates trunking in between. In this type of scenario, you have to be careful when you are using port security feature that you must allow 2 or 3 MAC addresses. You cannot allow 1 MAC address. If you allow 1 MAC address, then your phone might work, but your data or your user data ports will not work. Okay? So make sure you allow 2 or 3. And the reason it's 2 or 3 because it depends. Some switches look at the CDP information. And if they do look at the CDP information, then they need 3 MAC address to be allowed. If they don't use the CDP information, then you need to allow 2 MAC addresses. Okay? So I'm not going into the detail of how to configure these boxes. The main objective is to highlight that there is this problem, there is this function called port security, so go research on port security on whatever box you are using and apply this feature. Okay? But you have to consider when, because most networks today are using IP phones, so that's why I put this specific emphasize that don't hard code MAC address 1 on all the ports, otherwise all your IP phones and all your users will start complaining. So here is the configuration example on a Cisco switch. Remember I was telling you that when a violation occurs, there are several actions that you can configure. You can configure the port to go in a shutdown mode. Shutdown means completely cut it off. And there is another action called restrict. Restrict action, what it does, it will disconnect data traffic, but it will continue voice traffic. So especially when the phone is connected on that port, and when the port is seeing multiple bogus MAC addresses, it won't completely cut it down, shut down. It will continue the voice traffic and cut down the data traffic. Okay, so it can be useful to use this feature. And new features, I don't know where to go about that. You can read it. So as I told you, in the past you could, and not only in the past, even today, if you know that, for example, there is port number 5 where your server is connected, and that server is static, it's not going to move. So instead of using that dynamic MAC address, you can hard code the MAC address and say only this MAC address is allowed to be seen on port number 5. So you can do both. You can hard code MAC addresses, or you can use a dynamic MAC address feature, okay, whichever is suitable for you. You can also put.
If you hard code it, does that then permanently bind that in the CAM table?
Absolutely.
So that MAC address, if some other port claims it has it as well.
Absolutely. So the question is, when you hard code the MAC address to, let's say, MAC address 123 on port number 5, then you're telling the switch MAC address 123 can only be seen on port number 5. If it's in somewhere else, then it disconnects it. Okay? So you are hard coding the MAC address. Another feature in this port security is called sticky settings. And just in a nutshell, what sticky means is remember I told you when you power cycle the switch, when you reboot the switch, the CAM table goes away because it's in your DRAM, in volatile memory. Okay? So if you want to preserve that CAM table information for a power cycle, for a reboot, you can configure a sticky port settings. Okay? So it's just an optional feature to survive a reboot. Another thing to make a note is that, remember when I told you when you use a restrict feature in the situation where a violation occurs, you are saying don't shut down the port but do a restrict, and a restrict means shut down the data traffic but continue the voice traffic. So when you are using that function, you should expect some performance hit. Obviously you are under attack, there are multiple attacks going on, and then your voice traffic is also going on. So you will see some CPU going up. How up? It depends, it varies on the attack. But remember that this process in the switch has a very low priority, so you still will see some functionality is still continuing. So for example, your phone is working, there will be a little delay in the phone, but it will still work. If you are telnetted to the box and you type show run, you will still see that your box is performing and it's slow, but it will not be completely hosed. Okay? You will see a performance hit, but what they've done in architecture is they've given that process low priority. And when the process has a low priority, it doesn't chew up the whole memory. Okay? So there is a side effect, but it's not completely hosed. Yes?
So what you're saying here is this just the Cisco switches?
Right. This is,
In other words, everyone
No, this is when we are doing the restrict feature under an attack.
Right. Oh, under
Under
it.
an attack. So let's say I use a MAC-off tool and in 1 second I shoot 100,000 MAC addresses to you. So obviously the CPU has to process all those 100,000 MAC addresses on a single port. So this is under attack. The switch is under attack.
I'm moving several 100,000 packets, and they're all the same MAC address. How does the switch know the same MAC address without looking? And shift to the Ethernet port?
No, I didn't follow. A same MAC address on all the...
Accept the MAC address, right?
Hmm.
You have to validate that it can pass traffic. Is that CPU picking itself?
I'm not an expert to go into that detail. All I'm saying in this regard is in terms of security, when you have enabled port security on the port. So I won't go discussing the architecture of switch without port security. I'm not an expert to answer that. But hypothetically speaking, let's say you have port security enabled on that port. You have a restrict feature because obviously when you enable a feature, that is a performance hit in itself, right? Without the port security, the switch has a normal functionality. What is the performance characteristics? I'm not an expert to work on that. Make sense? Okay? I'll discuss with you offline on that. Because as I said earlier also, I don't want to comment on the performances of individual series or models or Cisco devices. All I'm trying to say is whenever you enable features, they come with a baggage, right? They will come with some performance hits. So you should be aware of that. Because voice, sometimes, and it's entirely optional, right? By default, absolutely. I mean, again, the comment is, you know, why bother? If you're under an attack, just cut it down and shut it down rather than putting it in a restrict mode and taking all the performance hit and all that. Absolutely, it's just an optional thing. As a matter of fact, to your point, by default, if you configure port security, by default, the action is shut down. You go ahead and change it to restrict if you want to.
The problem with shutdown is if you accidentally just plug another cable in,
You can shut it down.
got to then log into the switch and do another step on that.
No, there is an error disable recovery command, so you have to do that command. So yeah, see, there are all different variations. So it depends on your network environment, what is good for you.
You have to do that either way.
You can put a timer and it will auto recover. Yeah, you can do auto recover also.
So whether you do it this way or whether you shut down some stuff, just check it eventually get back on home state.
Yeah, and that is entirely up to your security policy. How do you want to handle attacks in this type of situation? Because if you auto recover, then maybe, I don't know if you are syslogging. How will you ever know that that port was under attack? By syslog? And will somebody bother to all the way go and check syslogs? But if it's in shutdown, then somebody really has to go in, investigate it, document it, and then unshut that port, right? So it all depends on your security policy, how you want to handle that incident, right? Do you want to auto recover yourself, or do you want to manually recover by filing an incident report? It depends on your security policy. So here is a slide. I'm going to build this pyramid. And this is the first layer of the pyramid where we are saying that port security prevents different CAM attacks as well as DHCP starvation attacks, which we will discuss in the next slide. Okay? So you will see as we build our presentation, you'll see this thing piling up. Okay? Okay, so now let's talk about DHCP. It's a very interesting attack, and this is one of the most dangerous attacks that I see personally, because they are very easy to launch. So on a high level, how does the DHCP function? We all know, right? You plug in a computer into the switch, there is a DHCP server, it says, hey, you know, I need IP address, I need default, I need subnet mask, and the DHCP server sends the information, all the stuff, and you are ready to browse, right? You are ready to use the network. So that's basically the high level setup of DHCP. Here is the low level, and you must understand the low level in order to understand the attack how the attack works. So first, in the previous slide when I said all this happens, how does it happen actually? When the client powers up, it sends a packet called DHCP discover packet. And discover packet is basically a broadcast on FFFF saying, is there any DHCP server on this planet? Can you please reply to me? So what happens? The DHCP server sends a packet called DHCP offer, which is a unicast packet. Unicast meaning because it knows the client's MAC address. So it sends a unicast, hey, I'm here, let me give you the information that you need. And then this guy is happy. He says, okay, I'm happy with that request. You gave me an IP address, a subnet mask, a default gateway, a WINS, a DNS, everything. I want that. Again, it sends the broadcast.
Why would it send a broadcast?
Very good question. Because there is a contention, but according to the RFC, you cannot limit this guy to only communicate to that dedicated server. There are multiple, in this scenario there is only one, but there could be multiple DHCP servers on the segment, right? And in most cases there are. And when it sends the discover, you will receive multiple unicasts. So when you have to send the broadcast so that all the others also know that you have accepted this offer and explicitly denying the other offers.
And that's contained within the payload of the packet.
Yeah, DHCP payload of the packet. It's a very good observation. DHCP ACK, obviously the DHCP server that we have chosen in the DHCP packet, it comes back with a unicast and everything settles down. Okay. Now in this diagram, for the future reference for our attack, remember the two packets, unicasts that the DHCP server sends are called offer and acknowledgement. Make a note of that because we will come back to that. So here are different DHCP messages, and you can read them for your reference. Now, another important note to make, because I'm going to discuss during my attack slide, is this part here. This is the DHCP packet. Okay? In the DHCP packet, there is a field called client hardware address. And client hardware address is the same, you know, that unique 48-bit hex number is also put in the DHCP packet in addition to the frame, in addition to the layer 2 frame. Okay? Because see, you have in OSI model, you have layer 1, then layer 2, and layer 3, right? So in layer 2, you have your Ethernet frame, where you have source MAC address, destination MAC address, and then you have the DHCP packet within that frame. So there is a unique client hardware address which is duplicated from the source MAC address. So you have the source MAC address in your source in the packet, which copies into the DHCP packet. I'll tell you the significance of this later on. Okay, so let's see what attack is possible in this scenario. So we understood how the basic DHCP works. Now, let's say there are two people connected. One is the legitimate client, and one is Mr. Yusuf trying to do some bad things in your network. Okay? So what we are trying to do, we are trying to do DHCP starvation. And what that means is, obviously when you have a DHCP server, you have a set number of IP address, a pool, let's say from .1 to .50, for example. So you have 50 addresses to hand out, right? That means 50 legitimate clients can obtain individually that unique IP address. Now what I can do here is I can throw DHCP discover 50 times and exhaust the whole pool. So when next time the legitimate guys comes to the server and says, sorry, I'm out of addresses. Right? So that's one of the type of attack we call starvation attack. So this bad guy tries to send multiple discovery times the size of the scope, 50 times, 100 times, 200 times, whatever. And obviously, the same number of times this guy will send the offer, and this guy will continue saying, yeah, I want that request, and the whole process completes the one we saw earlier. So this bad guy uses up all the IP pool from your DHCP server. Okay? So what does this happen? This is called denial of service against the DHCP lease for a legitimate user. When a legitimate user powers up, there is no more IP address to hand out. Okay? Make sense? Any questions so far? So how do you protect against this type of attack? What are the countermeasures? Remember I told you in my previous slide, port security not only solves CAM table attacks, but it also solves DHCP starvation attacks. Same solution. You limit the number of MAC addresses. Why? Because if we go back to our previous slide, when this guy sends the DHCP discovery, what is the important information that this guy is going to look for? The source MAC address, right? Because it will give you an IP address on the basis of unique MAC addresses. So he's going to be spoofing different source MAC addresses, bogus MAC addresses.
Does something validate that client hardware address with DHCP?
Yep, and I'm going to come to that in a second. Assume a basic DHCP server which does not do any of that kind of validation, and most of them don't. Only some do, and we'll come to that. But most of them don't, and the client keeps on sending that source MAC address, unique MAC address, and uses up the whole pool. So this type of attack can be resolved by port security. Simply lock down the port to one MAC address or two MAC address or whatever you want to, and he cannot take up more IP address than the MAC addresses that you have locked down. So for example, in this port security, we have locked down to one MAC address, so he can only get from the IP pool, he can only get one IP address for that one unique MAC address, because the next time he's going to change his source MAC address, he'll get locked down. Okay? Now, coming back, I'll come back to that in a second. Huh? So this was the DHCP starvation. Okay. Now another variation, another type of DHCP attack is called rogue DHCP server attack. What that means is, this bad guy now, he is trying to pretend to be a DHCP server. So now in this case, when a client comes in, sends a DHCP discover, there are two DHCP servers on the network. One is the original one, and one is this guy, bad guy, who's trying to be DHCP server. So whenever this guy sends a request, there is an offer, but from who? From the rogue server. Why? Because this is like a double attack. First, this guy kills the whole pool, takes the whole DHCP server down, uses the DHCP starvation attack, and next time he is trying to hand out his own IP addresses. Okay? So the whole process completes the same four packets: discovery, offer, request, and acknowledgement, but acknowledgement and offer is coming from the rogue server. So what is the problem with this type of situation? Yeah, fine, let the bad guy become a DHCP server. Why? What's the problem? The problem is that the bad guy can send you the wrong default gateway, he can send you a wrong DNS server, he can send you the wrong IP address, or whatever. He's trying to play with you. He's giving you wrong information. Man in the middle, right? So how do we protect this type of attack? There is a feature on the switch called DHCP snooping. A unique feature called DHCP snooping. And what that feature does, let me pull up all those things. What this feature does is, on the switch, you label each port as either trusted or untrusted. And when we say labeling, is you're just marking it. So you mark the server, whichever port it's connected to, as the trusted port. How do you do that? With this command. And you mark all the other ports which are non-DHCP server ports, as untrusted ports. And you don't need to mark them, because by default they are untrusted. So all you have to do is mark the port which is trusted by this command under the interface. So let's say this is connected to port number 20. So you go on the port number 20 and you say IP DHCP snooping, trust. You label that, that's one part. The second part is the global commands. And global commands meaning you enable DHCP snooping on a per VLAN basis. Because DHCP snooping function or feature is on a per VLAN. So let's say this whole thing was on VLAN 4 and VLAN 104, or for that matter you can put any commas or range, you can put multiple VLANs. But you have to remember that DHCP snooping is on a per VLAN basis. And you finally enable IP DHCP snooping on the global mode. Now what this function does, remember I told you in my first slide that there are 4 packets. There is a broadcast saying that I'm looking for a server, then there is an offer, then there is a request, and then there is an acknowledgement. So which 2 packets are important that the DHCP server replies? There is an offer packet and then there is an acknowledgement packet. What this function does, all it does is policing. When a DHCP packet comes into the switch, it says, hang on, which type of packet you are. Are you a DHCP offer packet? Yeah, you can go through. Why? Because you have marked it as a trusted port. Now let's see this port, the rogue server. When the rogue server is sending you an offer, it says, no, sorry, you are an untrusted port. You should not be sending an offer. You can send a discover. You can send a request, but you cannot send an offer. So all this function or all this feature is doing is policing the type of DHCP packets that is received on the port. Okay? Make sense? That is called the DHCP relay agent information 82. So you have to enable that if you're using DHCP relay agent in your network. So if the switch itself is the server, then you are not marked, because then the problem is not about the, this is a transit problem, not the switch itself problem. So in that case, it's a very good question. What if the switch itself is the DHCP server? Interesting. Yes, I believe so. Because if we make all of them untrusted, then still you should enable DHCP snooping, but you don't enable any trusted ports and mark all of them as untrusted ports. So obviously still the rogue DHCP server will not work, and only your switch will hand out IP addresses. Make sense? Thank you for that. Yeah, but then that's what you want to do maybe, right? That's what your purpose is, that you always want the switch to win in terms of the sending out the offer. Okay? So you're sure that there is no other DHCP server on the network. So again, it's a design thing and how you want to play with the features. Okay? So the DHCP snooping table basically creates what we call a DHCP binding table. And please make a note that this DHCP binding table is going to be important for the next 3-4 features that we are going to talk about. Okay? So basically, what is a DHCP snooping binding table? It's a table that maps all the IP addresses to the designated MAC addresses, to the designated port, and the designated VLAN. So the whole information. So let's say this DHCP server assigned this client an IP address 10.124.10, and it assigned on VLAN 4 on port number 3/18. All that information is locked down in the DHCP binding table. And how does it maintain that? Passively, it's just monitoring the DHCP exchange between the client and the server. When the client sends discovery, when the server sends offer, the binding table says, okay, this guy assigned this, all this information is indicated in the DHCP binding table. Okay? And we'll be using this binding table for many other security features on the switch that we'll see in the next few slides. It's a very important table. Not all operating system refresh DHCP on link down. In the event of switch failure, the DHCP binding can be written to boot flash, yeah, blah, blah. So some switches, they don't keep this DHCP binding table during the refresh or power cycle. So you can always, write it to boot flash or write it to an FTP server, because, as I told you, that if there is no information in binding table, that means no traffic can pass, because it's like as if it's a null binding table. Okay? So we must make sure that the binding table is preserved. Now, coming back to that problem that we were discussing earlier about the client hardware address. So let's say an attacker such as Gobbler uses unique MAC address for each DHCP request, and port security, we said, can prevent that, right? Because whenever a source MAC address is changed, port security can catch it very easily. But as we were discussing, that what if the attack used the same source MAC address, same interface MAC address, but it only changed this address in the DHCP packet? So there are two instances, right? There is a layer 2 packet where there is source IP, source MAC, destination IP, destination MAC, your IP header, and then there is a DHCP packet. So this source MAC address of your interface is plugged in two different places, in your source MAC address and in your client hardware address in the DHCP packet. Now the attacker is smart. He knows that the port security feature doesn't check the DHCP packet. It only checks your regular payload, IP header. And I'm not going to change the source MAC address there. I'll keep it unique. I will only change it in the DHCP packet, so that way I can do that starvation attack. So port security will not fix that problem. But the answer to your question is DHCP snooping does. DHCP snooping will check also the client hardware address corresponding to the DHCP binding table that I told you earlier. So not all switches does that. You have to be careful.
Are there any legitimate cases where that client hardware address would be different from the
Maybe relay agent, yeah. But in an attack situation, it is very common that the attacker only changes the DHCP client hardware in the DHCP packet, but not in the regular source MAC address. Yes. Now, in order to solve the DHCP rogue server, if there are switches that do not support DHCP snooping, let's say you are using a switch, a non-Cisco switch or a Cisco switch, which doesn't have DHCP snooping, what is another solution? Another workaround is to use VLAN access list. Okay? So I won't go into the configuration, but there is an alternative. It's not a very clear-cut alternative, but you can still use VLAN ACLs, VACLs to solve this type of attack. Okay? So do a little research on that also. So summary, DHCP starvation can be mitigated by port security. We learned that. Rogue DHCP can be mitigated by snooping feature. When configured with snooping, all ports in VLAN must be untrusted, right? Only the trusted port would be the port which is connecting the DHCP server itself. Check the default settings. We spoke about the client hardware address. There are some unsupported switches which will not run snooping feature, so you have to use VACL in that case. But whenever you are using VACL, it will not solve that client hardware rogue DHCP attack. It will only solve the starvation attack. Okay, so there are limitations. Again, all DHCP, this snooping thing is going to be marked in the binding table, and all entries will remain in the binding table until the lease time. So make sure if you have a network environment where you're using mobile laptops, for example, most of your network is. So make sure your lease time is small. Don't keep large lease times like 1 year or something. Make it small, 1 day or 1 week or something, because it doesn't refresh. Otherwise you will have so many, because if I disconnect my laptop, but the lease time is still there, the entry will still remain there. And we have fixed table limit. Remember that limit I told you earlier? Because if you run out of that table limit, then you have problem again. It's kind of a denial of service to yourself. Then it depends on the configuration. If you had port security there, it will think you are trying to spoof. So it depends on the lease time. So if you renew, if you do IP config / release and / renew, then it's okay. Right? But otherwise it will think like somebody is spoofing your MAC address on the other port because of the port security. Okay? So you have to be careful. Yeah, maybe do that, or maybe a simple thing is just, release, renew. So here's that slide that I told you, like we are building the pyramid. So port security, again refreshing, port security prevents CAM attacks and DHCP starvation attacks. DHCP snooping prevents rogue DHCP server attacks. So we'll keep on building this pyramid. So now we talk about the ARP attacks. So little background again, how does the ARP function? Oh, first of all, what is an ARP? Address Resolution Protocol. ARP is a basic functionality within the network to map the IP address to the MAC address. So for example, if you have different computers, everyone, like for example, I know my address is 10.1.1.1 or 10.1.1.2, but I don't know the MAC address of the other side. So in order to identify or map the MAC address with the IP address, there is a protocol called ARP. So what happens when you power up? You say, hey, I want to speak to 10.1.1.4. Who's 10.1.1.4? I want to know your MAC address. You broadcast that to the entire network. And whoever is 10.1.1.4 will reply, I'm 10.1.1.4. My MAC address is ABC. In this case, we are saying A. Okay? So that's the basic function how ARP works. You send an ARP packet, ARP request, and then ARP response, ARP reply comes back from the legitimate guy. Now within the same functionality, there is another feature or another function in the ARP which is called unsolicited ARP reply, which is sometimes also called gratuitous ARP. Sorry, I cannot pronounce. It's gratuitous, right? Gratuitous. I say unsolicited ARP reply. What this means is, in the previous slide, somebody asked for my MAC address, so I responded, right? I didn't just wake up and say, my MAC address is A. No. But in the same function, I can do that. I can just wake up one fine day and say, my MAC address is A, I'm IP address 10.1.1.1. It is called unsolicited ARP reply. Nobody asked me, I just proactively updated everyone in the switch, saying, here is my MAC address. So this is a function in the ARP RFC, according to the RFC. It's not good. It's not good because that is where our ARP attacks begin, using this functionality of ARP response, unsolicited responses. So when you send 10.1.1.1, my MAC address is A, everybody, what does everybody do? It updates its ARP entry, which is also called ARP poisoning. So you try to poison MAC address A binding to 10.1.1.1 to everybody's ARP table. Okay, it's called ARP poisoning. So how does it, how can you do this? There are many tools. EtherCap is one of the most common ones. You can download it from here, no rocket science. This functionality of unsolicited ARP reply, eventually poisoning ARP table for the other peers, you can launch a man-in-the-middle attack, and you can capture virtually every traffic, every communication between two devices passively in between without them knowing about it. Without them knowing about it. And I'll show you an example. FTP, Telnet, all these protocols, even HTTP, you are doing your banking and trying to transfer funds, or you're managing your device, telnetting, or all that information is transparently seen by the middleman. Here is a EtherCap tool. You can see the EtherCap is monitoring two devices, Telnet protocol, and all the username and passwords are seen. Even when you do show run, it will show you here on this box, like show run the whole config. I've done it so many times. You can virtually, and believe me, the original communication, host A and host B doesn't even know I'm doing this. So how do we do that? Oh, before we go to that, how do we do that? Remember I told you the problem in OSI is that if layer 2 is compromised, it doesn't matter I have firewalls, it doesn't matter I have cryptography, it doesn't matter I use SSL and certificate servers and all that, because your layer 2 is compromised. There are tools that can also present a dummy certificate, and you will accept that certificate, and all your encrypted traffic are also going through man in the middle. You won't even realize that. This is really dangerous. So how do you poison tables? So let's say this is the bad guy. Look at this diagram carefully. 10111, MAC address A, 10113, MAC C, 10112, MAC B. 3 individuals with 3 different IP address with 3 different MAC address. Now what will this guy do? He's going to send an ARP, unsolicited ARP. Remember unsolicited ARP reply? Saying what? That my IP address is 10112, trying to spoof this guy, poor him, and he's going to send his original MAC address. Okay? So what will this guy do? He'll say, oh, okay, your MAC address C, 10112, okay, I'll update my records, I'll update my ARP table. So in the future, whenever anybody wants to send to 10112, I will send to MAC address C. Because it starts layer 2 and above, right? Then it sends another unsolicited reply to this guy saying, I'm 10111 and my MAC address is C. So this guy updates his MAC ARP table saying, okay, I updated 10111 is MAC address C. So basically we poisoned these 2 guys here with opposite MAC addresses of this guy. Okay. So what will we do? The next time traffic flows like this. So whenever this guy wants to communicate to this guy, what is the IP address? 10111, but he's going to send to MAC C. He's going to make a U-turn and send the packet back on the wire. When this guy replies to him, he's going to reply to 10112, but he's going to send to MAC C, MAC address C, and he's going to make a U-turn and send the packet back to him. So they actually think they're communicating with each other, but it's actually making a U-turn like this. You understand how the communication works? It's all because the layer 2 has been compromised. Layer 3 has no problem. Layer 3, all your cryptography, all your firewalls, everything is okay. Your layer 2 is compromised. And these 2 won't even realize that they are transmitting and receiving traffic from someone else. And this guy is not changing anything on the packet. He's just rewriting the MAC address and sending it back on the wire. All he is doing is passively looking at the packets. This is called man in the middle. And when he's done, he's finished playing with you, he will fix it again. He will update the original 10112 with MAC B. He will update this guy 10111 with MAC A, and then go have his coffee. He'll say, thanks, I'm done. So they can communicate back normally. So how do you fix this type of problem? There is a function called DAI, Dynamic ARP Inspection. Again, this function is in relation to Cisco switch, but I'm sure if you're using a non-Cisco switch, I'm sure there is something similar. But in Cisco context, this function is called DAI, Dynamic ARP Inspection. And again, DAI is dependent on the DHCP binding table. Remember I told you earlier? Please remember DHCP binding is our foundation. If we don't have DHCP binding table, all the other features that I'm going to talk about will not work. So DAI is closely tied up with the DHCP binding table. So what happens? You enable DHCP snooping, just like I told you earlier in the previous slides. You also enable DAI. Now next time this guy tries to send these poison packets, the binding table inspects the 2 packets against what? Against the DHCP binding table. And he will know, oh, this guy should be 10113 with MAC address C. How come he's sending a packet with 10112 MAC C and 10111 MAC C? There's something wrong, right? Because it doesn't match the binding table. So it will deny the packet. Yep. Good question. The question is that there is a command or there is a function on devices to disable the functionality, the unsolicited ARP response, gratuitous ARP. You can disable that. So then there won't be any problem, right? You are killing the root cause. You're saying, I won't even allow unsolicited ARP response. Yes. But the point is, you have to abide by the RFCs. You cannot just disable it. Maybe there are some applications or some tools that are using it legitimately. That's why it's there in the first place, right?
Yeah, but
Yeah, absolutely. Absolutely. That if you turn it off by default, then there is not going to be problem, in my opinion. Yeah, it could be some different hosts. There is a comment? Yeah, only the router or switch you are disabling, but not the host. How can you tell the host, don't send me? How can you stop that? If you're using Linux box or a Microsoft box, the operating system, you disable there. On the router and switch, you can disable it. But if the packet is originating from the switch, if the packet is originating one step behind, you can't stop it. Make sense? Any other observation, comments, questions? So again, as we said, we are heavily depending on our DHCP binding table. If there is no binding table, DAI will not work. Yep, absolutely good observation. What if I'm not using a DHCP environment? I don't have a DHCP server in my network. So how will I compile? How will I populate my DHCP binding table? Because DHCP binding observes the DHCP packets, right? Request, offer, unicast, all that stuff. So if you don't have a DHCP environment, you can populate statically your DHCP binding table. So you can, I think I have a sample here somewhere, here. So if you have a non-DHCP environment, you can statically map a MAC address to a VLAN, to an IP address, to an interface. The same thing that a DHCP binding would do, learning from the DHCP exchanges, you can statically do that as well. Okay? So, but it is cumbersome. I mean, if you have like 100 hosts, but I mean, there is a workaround. Okay, going back. So, summary is DHCP snooping. DHCP snooping has to be configured so that the binding table is very important. DAI is also configured on a per VLAN basis, same concept. You can trust an interface just like DHCP. So even in DHCP, remember you had a trusted port as well as an untrusted port. Same concept in DAI. Be careful about rate limiting, varies between platforms. What rate limiting means that you also have to be aware of the number of packets that are coming in into the port. So you can limit the number of packets per second that DAI can inspect on the switch. Okay, so look into that as well. For voice especially, you have to make sure that you tune that rate limit carefully. So here is the configuration. I'm not going to go into the detail how to configure it, but just for your reference. And by the way, these slides will be available, so you can always look it up. Here are some syslog messages that you can see when a violation occurs. So whenever a violation occurs, it will tell you that I found this problem and DHCP snooping, one invalid, blah, 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 and shutting it down. This is the non-DHCP we just talked about. Again, if the DHCP binding table is blank, no traffic can pass through if you have enabled DAI. So you have to be very careful before you enable DAI on your switch. Make sure your binding table, DHCP binding table is fully populated and converged for that matter. Entries stay in the table until these run out. All switches have a fixed size. These are the sizes and it can vary. Okay? So again, as I was telling you, that if you run out of size, then again it's a problem. So keep your lease time shorter. If you have large lease time, you will quickly run out of size. Summary. Yeah, another alternative. Remember, in each of my countermeasures, I've told you about a Cisco way to do it and a non-Cisco way to do it. So in order to protect this type of attacks, there are some intrusion detection system IDS devices which can also monitor unusually high ARP packets back and forth. So you can protect using IDS. Another way to mitigate this is using an ARP watch software. ARP watch is a free freeware available to track IP MAC address. But again, I mean, they are available, but it's really hard to manage it. You have to put RPOC on each VLAN. You have to statically map all that stuff. So there are workarounds, but they are painful. If you do it on the switch, it's much easier because you are sitting in the network path and you don't have to do anything extra. So going back to our pyramid, port security, snooping, DAI. Okay? Remember, DAI is heavily dependent on DHCP snooping. However, port security is not dependent on DHCP snooping. Okay, spoofing attacks. There are two types of major spoofing, and I think we mostly covered the spoofing previously, but there are two major types of spoofing: MAC spoofing, layer 2 spoofing, and IP spoofing, layer 3 spoofing. Okay? There are different issues that can happen when you spoof one or the other, or both for that matter, and I'll show you in the next slide. So what happens if you are spoofing? Same slide. If you are spoofing MAC address, incorrect source MAC address, the attacker will look like someone else. So for example, if this guy sends a packet spoofing MAC address B, when this router receives the packet, it will look like as if this guy is sending that packet. So you're trying to perpetrate someone else in the network. Okay? Similarly, when you are spoofing IP address, all the traffic, this is very effective in man-in-the-middle attack when you are spoofing IP address. So whatever packet is sent will never reply to the attackers. For example, if I am spoofing 10.1.1.2, the reply will always go this way. The reply will never come back this way because I am spoofing somebody else's IP address. So this is very common in Smurf attacks. So you know ICMP Smurf or ping of that. So I send a ping ICMP packet, but the response will come back here. So if I send 1 million ICMP packets here, all the responses will come to the guy whose IP address I'm spoofing. So this is called ping of that ICMP Smurf attack, and the technique that that type of attack uses is called IP spoofing. Or you can do both IP and MAC address spoofing. And this is really the dangerous one, because when I spoof 10.1.1.2 and MAC address B, send the packet here, router A will think that actually this guy is sending me those bad things, right? Because it's a complete identity. It's not half identity. In the previous two scenarios, it was half identity. Either you spoofed MAC or either you spoofed IP. But if you spoof both, then you are actually completing the whole identity of someone. That's the worst dangerous part, because this guy is going to blame you for everything. So how do we protect against this spoofing? On the switch, again, there are various tools or various, how should I say, various mechanisms to protect against this type of attacks, but I'm talking in relation to layer 2 switch. How do you protect this on a layer 2 switch? And the answer is IP source guard, IPSG. IP source guard is another new feature that monitors spoofing on a layer 2 device, on a layer 2 port. Remember, this port is not a layer 3 port, it's a layer 2 port, access port. But there is a function, there is a feature on a switch which can do that. And again, what does it rely on? It relies on DHCP binding table. If you don't have DHCP binding table, how will the switch know what MAC address, what IP address is living on which port, right? So again, you enable DHCP snooping, you enable DAI, dynamic ARP inspection, and you enable IP source guard. Tell me one thing, why would I need IPSG when I already have things like DAI and DHCP snooping? Don't you think IP source guard is a little redundant here? I already have DHCP snooping, I already have DAI functionality. Bingo. DAI is an inspection mechanism, is a policing mechanism, but only for ARP traffic. For any non-ARP, for example, for all the other packets, other IP packets, DAI will not inspect them, because DAI is specifically about about the ARP inspection, right? So we need IPSG hand in hand with the DAI and with the DHCP binding table, okay? So again, coming back to my original thing, let's say this guy is, the green line is it's trying to spoof MAC address, the purple line is trying to spoof the IP address, or the yellow line is trying to spoof both IP and MAC. So what do? Whenever this type of packets come in, we correspondingly check our DHCP binding table. If they don't match, we block it. Okay, simple as that. So again, IP source guard is heavily depending on the DHCP binding table. So DHCP snooping must be configured before. IP source guard is enabled on a per port basis. DAI was configured on a per VLAN basis. Port security was configured again on a per port basis. Okay, so IPSG is also per port basis. Again, IPSG can be configured to track MAC address only, or IP address only, or both. Depends what you want to enable. So as I was saying, you can track IP only, MAC only, or both. It's just a note here that most enterprises do not need to check MAC address with IPSG, because if you have DAI configured, it pretty much takes care of it. But when it comes to both IP and MAC spoofing, then DAI will not help you. So you need IPSG. And here are two different ways to configure it. This is for IP only, and this is for IP and MAC. There's only one line difference. So just do a little research what this does. So, but these are the two different ways. So again, back to our pyramid, you have port security, snooping, DAI, IPSG. So finally, just a little general attack, spanning tree. We all know what spanning tree is. Spanning tree protocol to identify a loop-free topology. In a spanning tree, a most common problem is to identify the root bridge and to select or elect the root bridge. So the best case scenario is you avoid spanning tree. How to design a loop-free topology. But let's say you don't have that type of situation and you need to use spanning tree. So how do you protect spanning tree issues? So first of all, what are spanning tree issues? So here is a simple scenario. There are two switches. There is one switch which is the root switch, and this is the active port, and these are the block ports, right? So traffic goes like this, not like this. So what happens? This bad guy tries to send BPDU packets, bridge protocol data units, and BPDU packets are to trigger the spanning tree election. Okay? So when the spanning tree converges, there is around 15 to 20 milliseconds cutoff. The network is converging, and your switch is not going to forward packets because it's selecting the root bridge. So whenever your bad guy becomes root bridge, obviously he takes ownership, and this link now all the traffic goes like this. Okay, so he was able to become a root bridge by sending a bogus spanning tree packets, BPDU packets. How do you protect that? There is a function called BPDU guard, and BPDU guard, all it does is it blocks the port whenever it sees a BPDU packet coming in. So all you are saying is, on the access port, where should you enable BPDU guard? On all ports facing the user. So if you know these are all users connected, you shouldn't be sending BPDU in the first place. As soon as you see BPDU, you say shut it down. Okay? Secondly, there is another function called root guard that also protects the selection of the root switch on the network. So if you have hard-coded root switch and you don't want any other guy to become a root switch, and if he's sending you this BPDU packet, you block it. Okay? There are these two functions, root guard and BPDU guard. Just running out of time. CDP, Cisco, yes. Yeah, but you can still do that, but then you have to hard code the root switches. I know what you mean. Unfortunately, there is no, and I'll take your comment, we can discuss it offline. But the general answer is no, there is no integrated security in the STP protocol itself, spanning tree protocol, to include MD5 or something. CDP, again, Cisco Discovery Protocol is available on all Cisco switches, on all Cisco device. CDP, unfortunately, is unauthenticated and clear. It gives valuable information. It gives you all the information of what is connected, which iOS, which port. But that good information can be abused also sometimes. It could be bad. It could be misused. So if you don't require CDP, turn it off. You can turn it off on a per port basis or globally. Okay? So CDP is good, but sometimes it's not good from a security perspective. If you don't need that info, just turn it off. Yeah, and always, usually this whole session is about internal attacks. So someone on your network. It's not external. When we started the session, I said 50% of the time people think that I'm not attacked. However, they are attacked by the own internal users connected to your internal network. So they can abuse CDP information to map the whole network. CDP, there was a vulnerability in CDP. So if you are using CDP for any reason, please make sure that you are using the correct iOS images, because there was a security advisory. You can look it up, and there was a memory allocation problem. So you better use this iOS or above. If you're using iOS below this, then you are going to be vulnerable to that CDP security advisory. Another main problem is switch management. So we spoke about all these wonderful features, IPSG, all the different tools and features, but at the end of the day, if the attacker or intruder is able to access the switch, he can turn them off, right? He can simply switch it off or disable them. So you have to make sure that management is closely protected, management of the switch, okay? So either you use a secure protocol such as SSH, or you use out-of-band management. There are different techniques to do out-of-band management, but the most secure way is use SSH, okay? So summary, obviously we spoke about all these different features. Best practices, this is a summary of all the things I have said in my 80-90 slides. So these last two slides, this 1 and 2, is the summary of all the things that we discussed so far. You can say layer 2 best practices. These are the things you should be looking into when you go back into your network. Okay? Any questions? These slides will be available, so please make sure you read them. Any questions? Sorry we ran off for 5 minutes, but I hope it was useful, and thank you very much. And if you are interested, my next